Welcome back to Made Academia. We are still under the vectors. So now we have talked about how to find maybe we are asked to find distance covered by two vectors using the knowledge of Pythagoras theorem. At the same time, we talk about how to find a scalar product. And I said when we have scalar product, it's nothing but a dot product. And in that case, we use the knowledge of the direction that we have ijk, and we said when we have I dot I, when an object or a particle have the same direction, either we have I dot I, or we have j dot j, or we have k dot k, that one is 1. But if they have different direction, maybe we have I dot j, or j dot k, or I dot k, that one is 0. So we solve many examples on that. So now the next one we are going to talk about is a vector product. Vector product. So under this vector product is also known as a cross product. You know, I told you that when we have a scalar product is what we call a dot product. So at the same time, when we have a vector product is what we call cross product, just like this. In this case, we are having something like this. If you're asked to find this is not A multiplied by B, this simply means that A cross B. So how are we going to go about that? It's also simple and straightforward. You know, when we have rotation of quadrant, rotation of vectors, but here I will make use of a determinant method because that one is also simple to approach. How can we use a determinant to solve a vector product or a cross product? In this case, let's say if you are given two vectors, you know, we're using the knowledge of a cofactor. When we have cofactor is nothing but plus, minus, and plus. So what is the step? If you are given two vectors and you have to find the cross product, the first thing you need to do, you arrange those who have direction I together with the one that have direction J, together with the one that have direction K. Then after that, you will take the values of them. That, for example, the one that have I, it will be one side. The one that have J, then you'll be taking the cover-up method. How are we going to go about that? Let's say, for example, let's say I was given a vector like this. Say if vector A is equal to 2I plus 3J plus 5K, and we are given B to be, let's say, 4I plus 3J plus 5K. They now say find A cross B. So now I told you A cross B is not as if you have to multiply A by B. Cross is just like we are looking for the cross product, or we call it a vector product. So how are we going to solve this one? We have many ways of approaching this problem, but I'll be making use of a determinant method because that one is more easy to even solve and it's also straightforward as well. So now, how are we going to do that? Draw something like this. Now, you know, there in the problem we have three directions, right? Which one? We have I, we have J, at the same time we have K. So let's bring it out. We have I, we have J, at the same time we have K. So the next one is we take the number that have I. You know, in the problem itself, the number that have I is 2 and 4. Can we see? In the problem, what we have that have I under A is 2. The one that have I under B is 4, right? So the same thing applicable to J. The one that have J under that we have 3 and 3, you can see. The other K as well, we also have 5 and 5. So I hope you are getting it. So the first step to be considered, we bring out the three directions that we have. We have I, we have J, and we have K. So we check the two vectors. The one that we have under, the one that have I under A is 2. That's why we have 2 here. Under B, we have 4. The second one, we have 3 and 3. Under K, we have 5 and 5. Now, if I take a look at the cofactor that I mentioned, we have plus, minus, and plus. You can see. So what does that mean? It means, let's just use this one to demarcate it. It means the number that's under I is 2 and 4. The one that have J is 3 and 3. The one under K is 5 and 5. How are we going to do this one? It means if you are going to consider I, you will not take the number under I. you will take the one we have under J and under K. If you are under J, meaning you will not take the number under J, you will take the one you have under I at the same time under K. If you want to take K out, it means you will not take the number under K, you will take the one we have under I and under J, just like a cover-up method. How? I can have plus I, you see, the one that I have under I is what? 2 and 4. You are not going to take that one. You just take the one you have under J and under K. That is 3, 3, then 5 and 5. I hope you are following, right? Nice. So now I'm going to the second one now. Minus J. You can see the one we have under J is 3, 3. I will not take that one. I will take the one I have under I at the same time under K. Meaning we have 2, 4. You see? 2, 4. Then we have 5 and 5. I hope you are getting the logic right. Wow. So can you try the last one for me? How are you going to take the last one? Since I'm under K now. Can you try that one? Yeah. So that means we take 2, 4 and 3, 3. Good. So that means that we have 2, 4. Then we have 3 and 3. So it has become 2 by 2 matrix. That is, that's 2 now and 3 columns. So how do you want to do that? This will come, this follow. So normal method, determinant of matrix. So here we have plus I. Now it means this number and this number will multiply each other, and then this one too will also multiply, but this will come before this. That is 3 times 5 minus 3 times 5 minus 3 times 5 as well. Are you following? Now the second one we have is minus J. See this one as 2 times 5 minus 4 times 5. The last one we have plus K. So that means that we have 2 times 3, then minus 4 times 3. Please take note of this. This will come before this one. Now, so here we can have plus I, 3 times 5. That one is nothing but 15. Minus 3 times 5 as well is also 15. Minus J. 2 times 5, we are going to have 10. Minus 4 times 5, we are going to have 20. Then plus K, the next one, 2. 2 times 3, 2 times 3, we are going to have 6. Then 4 times 3, we are going to have 12. We just simplify the number. So now we want to open the bracket now. So here we have plus I. Now 15 minus 15. 15 minus 15 definitely is going to be 0, right? Now fine. So minus J, 10 minus 20. What are we going to have there? Yeah, so that is minus 10. Then plus K. 6 minus 12. What are we going to have there? Yeah, good. This is minus. So here I can have this one to be I times 0. That's going to be 0 vector. That is 0. Minus times minus of this, we are going to have plus. Then J times 10, and we have 10J. Then plus times minus here too as well, and we have minus. K times 6, of course, we are going to have 6K. You can see you make use of a determinant method to obtain the cross product of vector A and B. So in some problems, some situations, between the two numbers, one of them may have a negative. We are going to follow the same process, the same pattern. Let's say, for example, let's say we are given this problem to solve. Let's say we are given this to solve. Maybe they said if vector x is equal to 3i minus j minus 3k, and vector y is 2i plus 4j minus 2k. They now said find x cross y. So they can say find the cross product. Find the cross product of x and y. It's still the same problem, just like the statement they use depending on the problem we are solving. Now, so I'll still follow it the same way. That I told you earlier, the first thing for you to do, you pick out the 3 directions that we have. So let's pick it out. The 3 directions that we have I, we have j, at the same time, we have k. So from the problem, let's analyze the numbers that have I. So we can see under x, the one that have I is 3. So the one that have I under y is 2. So under j, you can see what we have here is minus 1. So I have minus 1 here. Under the second one, we have 4. Then under this, the two numbers have negative, that is a minus 3 and minus 2. You understand? Yeah, good. So now, as I told you, make your cofactor plus, minus, and plus. Meaning, the number that is under I is 3 and 2. The one that is under J is minus 1 and 4. Under K is minus 3 and minus 2. So if I'm taking I will not take the number under I will take this and this. That is how we have minus 1 and 4, minus 3 and minus 2. Then second one, minus J. The one we have under J is minus 1 and 4. I will not take that one. We take 3, 2, at the same time, minus 3 and minus 2. Then the one we have under K, you can see under K what we have is minus 3 and minus 2. I will not take that one. I will take this and this. That's going to be 3, 2, then minus 1 and 4. You can see 3, 2, minus 1 and 4. We follow the same process just like the way we solved the first example. Cross product using determinant 2 by 2 matrix. That means that we have plus I, this for this, this for this. That is how we have minus 1 times minus 2. You can see it's not as if we bring the minus here. The problem we have is from the question itself, because the question itself has a negative sign. That's why we have minus 1 times minus 2, then minus 4 times minus 3. Why did I bracket this one? Because the value that we also have also contain negative. Okay? So here we have minus J, the same thing applicable to this. That's 3 multiplied by minus 2 multiplied by minus 3. Then the last one plus K, the same thing. That's 3 times 4 minus 2 times minus 1. So now, the next step now, let's multiply them as usual. And we have plus I, minus times minus. You know, of course, if you have minus times minus, it's nothing but what? Yeah, good. So that's minus times minus is plus. Then 1 times 2, we have 2. Now, minus times minus here, you can see I have minus here. And the number I'm using also contain minus. So minus times minus, we are going to have plus. 4 times 3, we are going to have 12 minus J. 3 times minus 2, we are going to have minus 6. Minus times minus, we are going to have plus. 2 times 3, of course, and we have 6. Then plus K. 3 times 4, we are going to have 12. Then minus times minus, we are going to have plus. 2 times 1, we are going to have 2. So here we are going to have plus I. So 2 plus 12, 2 plus 12 is nothing but plus 14 minus J. Minus 6 plus 6, of course, we are going to have 0 plus K. 12 plus 2, we are going to have 14. You can see how we do that. You get it right? Yeah, very nice. So I times 14, we are going to have 14I minus J times 0. J times 0 is going to be 0. Then K times 14, of course, we are going to have 14K. So, you can see in the first one we solve, it gives us 2 directions. This one also gives us 2. It doesn't matter. It depends on the problem you are solving. We are just lucky here that we are just having a result here to be only 2 results. Having, what do we call it? Having just 14 and here we have I and J. And the one we solved earlier, we have what we call, I think we have I and K. I and J as well. So anyhow we have it is still correct. So in some problem, let's say we are solving equations and we see that it's only 2 directions we are given instead of 3. Maybe we are given only I and J. We must make it to the 3. What we are trying to say in essence is that maybe I'm solving a problem and I see that the value we are given is only 2. Maybe we have I and J. So if I'm solving a problem and I see that they only give me I and J, or I was given I and K, I have to make it to be 3. How would I do that? I've just introduced 0 vector. Maybe let's say we are dealing with A and B, and we are given let's say we are given 2I plus 3J. That means K is missing. So what did I need to do? I'll just add the 0 vector of K. That is 0K. Let's see an example of that. Like Didi said, if vector U is equal to, let's say, I plus 3J. Vector V is 2I plus 4K. Or let's say, anyhow, and they said, find cross product of U and V. So that's the one problem. It's still the same thing. If you look at the first one, something is missing, right? What is missing there? Yeah, good. J, K is missing. I can say is 0k here, at the same time here, I can also say is 0k. Even if it's just, maybe they are not, what missing the first one, the second one are not the same, we are going to introduce a zero factor to the two of them. So the same thing, the same method, then I'll bring out the two. I have I, J, and K. So the one we have under I, you can see we have 1 here, right? That is 1 and 2. Here we have 3 and 2. So here we have 0 and 0. So plus, minus, and plus. I will follow you the same process. The one we have under I is 1 and 2. I will not take that. That is a plus I. I will not take the one we have under I. I will take this and this. That's going to be 3, 2, 0, 0. Then minus J. The one we have under J is at 3, 2. I will not take that one. I will take this and this. That's going to be 1, 2, then 0, 0. You can see the logic. If you are under I, we are not taking the one we have under I. We are taking the one we have under J and under K. So same thing also applicable to the rest also. So now plus K. You can see the number I have under K is at 0, 0. I will not take that. I will take the one I have under I and under J, which is a 1, 2, 3, 2. It's a 1, 2, 3, and 2. So it has become 2 by 2 matrix. So down here I can have plus I. So it's just like that is a 3 times 0. You know, I told you the one we have here must come before this one. So 3 times 0 minus 2 times 0 minus J, this one 2. 1 times 0 minus 2 times 0. Then the last one plus K, that's going to be 1 times 2 minus 2 times 3. Okay, fine. So here you can see if I multiply 3 by 0, of course, we are going to have 0. 2 times 0 as well, we are going to have 0 minus J. 1 times 0, we are going to have 0. 2 times 0, we are going to have 0 plus K. Then 1 times 2, we have 2. 2 times 3, we are going to have 6. So now here we are going to have plus I is 0 minus 0. Definitely, this is nothing but 0 minus J is 0 minus 0. We are going to have 0 as well. Then plus K. 2 minus 6, we are going to have minus 4. So I times 0, that is going to be 0 vector of I. This one is also 0. Then plus times minus of this one to save our time, that's going to be minus K times 4. Then we are going to have 4K. So that means the cross product of U and V here is going to be minus 4K. That's all about what we have for the cross product. If in some situation you'll be asked to prove, maybe they said you should show that A cross B is equal to minus B cross A. You just have to check if the two, or they might use another letter to represent the two of them. Just follow the same process, the same logic, the same pattern of how we approach this problem, then we can make use of a cross product. So the next one we have is how can we find the magnitude of the vectors? It's just like resultant, just like absolute values. Maybe you are looking for the exactly just like the way we are solving. Let's see, like Pythagoras. Can we see Pythagoras? How we are finding the using the hypotenuse square is equal to that. So it's still the same thing. If I were given, let's say we are given vector xi plus yj. Let's start from 2, just 2. If I was to find the magnitude of a vector, magnitude. Maybe I was asked to find magnitude of vector. So just like the way we are looking for, you see now. Let's say I was given 2 vectors. If I want, so it only is represented by this, just like absolute. So if I want to find the magnitude of this, I can have the magnitude of this to be square root of the value that I have, the coefficient of I and j. That's going to be x squared plus y squared. You get that? Just like taking their coefficient, even if it's still directions. Let's say we are given vector to be this. Let's say we have xi plus yj plus z. You can see in this problem there are 3. So it's still going to be the same. So magnitude of this is going to be square root of x squared plus y squared then plus z squared. Just have to take their coefficient and find it what? And find it square root. Let's say, for example, they said if r is equal to 3i plus 4j, they now say find the magnitude of r. Find the magnitude of r. Or they can say find this one, or maybe the of r, or they put it in this way. So if I want to do that, magnitude of r here is going to be what? Square root of, you can see the coefficient of this one is 3. That's going to be 3 square. Then second one is also 4. That is 4 square. Then here we have 3 square. That's going to be 9. 3 square means 3 times 3, right? Good. Then 4 times 4, that's going to be 16 as well. Then I can have this one to be square root of 25. What is going to be the square root of 25? Yeah, fine. So square root of 25 is going to be equal to 5. If in some problem, let's take a look at a question from University of Ilorin that they said, take a look at that. Question from University of Ilorin. They said, given that A is equal to 3i minus 2j and B equal to 6i plus 8j. They now say find modulus of A and magnitude of A plus magnitude of B. Look at this one. You see, what they are trying to tell us is that we should firstly find the magnitude of A, then we find the magnitude of B, then we add them together. That's what they are trying to tell us. I hope you get it right. This is the magnitude of A, then the magnitude of B, then we add the two together. So how? Let's follow for the first one. So magnitude of A here is going to be square root of, the coefficient of I that we have here is 3. That's going to be 3 squared plus, of the second one is minus 2, because you can see it's not 2 here, it's minus 2. So that is minus 2 squared. So here we have 3 squared is going to be 9. Minus 2 squared, it means minus times minus, and that's going to be plus. 2 times 2, of course, we are going to have plus. So here we have square root of 13. Square root of 13, you can see, do we have a perfect group for 13? Yeah, so of course there's no square root for 13 because 13 is irrational numbers. So let's check for B. So that's going to be square root of, that's 6 square plus 8 square. So here we have 6 square. That's 6 times 6, we have 36. 8 times 8, we have 64. So here I will just have 100, right? So 100 have a perfect square root. So square root of 100, of course, you are going to have 10. So meaning the modulus of the magnitude of A, we have it to be root of 13. The magnitude of B, we have it to be 10. So the question now says we should find absolute of A plus B. So that means I'll just substitute the values. What I get for the first one is root of 13. And what I get for the second one is 10. So meaning the result of this one is root of 13 plus 10. So we cannot add them together because root of 13, unless if you want to leave your result in form of decimal point. So let's do that. Maybe the question you don't leave the problem in form of a root. You can press this one. If you press the calculator, root of 13 plus 10. So your answer is going to be, if you do that, what I have in my calculator here, I got 13.606 approximation. So it depends on how they live there. You can see how to find the magnitude of the vectors. It's also simple and straightforward.